Hello. We're gonna wait a bit for more people to come. Okay. Can everyone hear me?
Yeah.
Okay. Yeah, let's wait like 2 more minutes. Yeah, welcome everyone. We're still waiting for more people to join. Okay. Right, I'm just gonna start. So yeah. Can everyone see the screen? Can everyone see the slides? Yes. Okay, so right. So welcome to the introduction to the SMO junior lesson. Okay, I'm Teddy Ong. So first, a little bit about me. So I'm currently studying mathematics at Trinity College, Cambridge. And I've gotten first class honors and I'm top 10 in my cohort in Cambridge consecutively for the past 2 years. I graduated at NUS High School with honors in math and physics. And I got a GPA of 4.9 out of 5. And yeah, I also got excellence awards for history, for physics and history. As far as Olympic goes, I was a gold medalist for the International Physics Olympiad 2017. This is when the Singapore team ranked first in the world. And silver medalist for the Asian Physics Olympiad. And as far as math goes, I was in the math national team for several years. And I've gotten top 30 for SMO Open and SMO Senior. Yeah. So I've also participated in APMO and I've gotten honorable mention. So as you probably have seen from my website. So in 2022, so I've been teaching this Math Olympiad for a couple of years now, like 4 years now. And this year, my students, some of them ranked 4th and 3rd in SMO Junior and Senior, and 80% of the Saturday class, they got a gold medal, and half of the Sunday class, they also got a gold medal as well. In 2021, some of my students got 1st and 3rd in SMO Junior, and also we've got a Sec 2 student who got a gold medal for SMO Open, and 5 of my students were in the top 10 for SMO, for all the SMOs, and more than 6 students were then selected to be in the national team. So I think at least half the students are in the junior and senior team already. In 2020, we've got 2nd place, we got 3 in top 10, and we've also got the only gold medal in RGS. Yeah, so you can see my website for more details about the track record and then my achievements and different courses. So an example would be one student who joined the class in February 2020. He says he spends about 14 hours a week doing Math Olympiad. As you know, the lesson is 2 hours a week, so you need to put in effort outside of the lecture times. Okay, not just doing homework, but also doing your own practice and own learning. And he very quickly got SMO Junior and Open gold, and now he's in the national team. Okay, so here's just an overview of all your math competitions. So in year one and year 2, you can do SMO Junior. You can always do SMO Open. And if you got top 30 in SMO Junior, you get to the junior team. After you get to the junior team, you get to the senior team if you pass the junior team test. In year 3 and year 4, you can take SMO Senior and SMO Open. If you get to the top 30 in SMO Senior, you get to the senior team, which is the end. And from the senior team, you can go to CWMI, so that's China Western Mathematics Invitational, and CGMO China Girls Math Olympiad, and APMO Asia Pacific Math Olympiad. And then in SMO Open, if you get top 30, you go into the national team. This is where you can go for all the competitions plus IMO. Okay, yeah. So in terms of comparatively, there's also American competitions, as you know. So as you know, there is AMC 8 and AMC 10, AMC 12, which goes to AIME, AIME, which goes to USA MO, but unfortunately, unless you're a US citizen, you can't actually participate in USA MO. So the best we can do is participate in AIME. Yeah. On the physics side, similarly, we have IFO corresponding to IMO and APHO corresponding to APMO. Physics there are less competitions. So in year 1 to year 4, you do SJPO, and in year 5, you do S4. The corresponding American competitions, I think, are basically non-existent in Singapore. So you don't really have to worry about them. Yeah. Okay. So the American competitions, math competitions, are useful because when you apply to American universities, they will ask you for your AMC and AIME scores. Okay, so here is the graph of difficulty against and the topics, how far away from pure math it is. So in the central axis, we have algebra, geometry, number theory, and combinatorics. This is pure math. Okay, and the round circles are, so green is junior, the circles are round 1, the squares are round 2. So obviously the round 1s are not as difficult as the round 2s, and it increases in difficulty. The point I want to make is that senior contains some trigo and logarithm, open contains some vectors and limits and 3-dimensional geometry, so it becomes less and less, a little bit less pure math. So this is for people who are learning, for regular syllabus people, to have some chance of doing the problems. In any case, all the actual competitions are all only pure math. So As you get past the junior round 2, you go into a junior, as you get junior top 30, you go into a junior team. You can then progress to a senior team, which can then go for these competitions. If you only from the open round 2, you can go into a national team, which can then get selected for the IMO. Okay. Yeah. So here's an overview of SMO Junior. As I said, the 4 topics are algebra, combinatorics, geometry, and number theory. And in round 1, if it's still the case, it's 5 MCQ questions and 20 short answer questions. No working, just the answer. And then round 2 is 5 open-ended questions where you have to write proofs. So I think many of you would not have written proofs before. And it does require a lot of effort to learn how to write the proofs. So we will work on that. So the lectures that I'll give will be a mixture of easy short questions and also long and open-ended questions. Okay, so you will probably see in the advertisement, these are the sample questions for each topic that we'll be covering. So we'll be first doing algebra. So this will introduce to you algebra completely different to algebra what you've been doing before. This is doing algebra sort of for algebra's sake, where you can be doing things like factorizing and solving and simplifying without ever caring about what the solution is or if the solution exists or anything like that. So you need to get better at sort of the abstract manipulation. And you'll see more and more letters and more constants and less numbers. Yeah. So we algebraic manipulation, solving equations, factorize. There's so much factorization to do in SMO. So it's very important that there are lots of identities for you to remember as well. Fractions and fractional equations. Then non-negative numbers and Vieta's theorem. Vieta's theorem is really the most important chapter of all of this. Then we have geometry, so we have triangles, parallel lines, and proofs. Okay, and congruence and area. And combinatorics and number theory are relatively similar to what you've been doing in primary school, so there are less of that. So counting, additive and multiplicative principle, and coloring. And for number theory, we have parity and prime and composite numbers. So if you read these questions, they are not trivial. They need some thinking. And obviously, I'll teach you all the techniques that you need to do with these things. And there's a little bit of more difficult algebra, which is the undetermined coefficient method. Okay, so there are 20 chapters. We expect to spend about 2 lessons on the chapter. So that's 40 something lessons. So that's an entire year of syllabus, of course, plus actual paper practice. So at the end of the course, near June period, so like starting, April, May, we're going to start practicing the SMO papers. Okay, anyone has any questions about the syllabus? If not, we will do some examples. Okay, so just to get you to have a feel for the flavor. So this SMO Junior 2021, question 12, what is the value of this? Have a look. So in the class, right, basically, I'll also tell you to have a look at the question and tell me any thoughts you have. So it can be any thoughts from things like, I don't know, to, I don't want to calculate this, to, I know how to calculate, like literally anything. And you can respond by talking or typing in the chat if whichever you're more comfortable with. So, any thoughts? Anyone? Wait, okay, wait. How many students or parents do we have? Because I presume most of you are students, or most of you parents. Okay, so I guess the first thought here is that I don't want to calculate this. This is boring. Right. So yeah, I mean, of course it's boring. So what are we supposed to do here? Well, in fact, this is a pretty well-known thing. Okay. So what we're going to do is we're going to let so I'll just use the annotate and write on the screen, basically, and then you can copy it down into your notebook. So what we're going to do is we're just going to say let x be 220, difference of squares. Okay, indeed, difference of squares. So you can let x be 290 or 220, it's completely up to you. So we have, if x is 220, because I don't want to deal with 219 squared. Actually, it doesn't really matter. So we're gonna have x minus 1, x plus 1, x plus 2, plus 1. We deal with the square root later. So what is this? Well, what I'm going to do is I'm going to pad the front and back up. So this is going to be x squared plus x minus 2, x squared plus x. And if you let y be x squared plus x minus 1, then this is really y minus 1, y plus 1. And this is really y squared minus 1. So if you plus 1, it'll just be y squared. So if you square root it, the answer would just be y, which will be 220 squared plus 220 minus 1. And you can calculate that. So of course, I assume that you've memorized all your squares at some point. So you can just calculate this. Okay. And you will get the answer. All right. Does anyone have any questions? So I presume this is what you meant by difference of square. All right. If you're all happy with this, well, let's see another example. So this is now a combinatrix problem. So yeah. So combinatrix is like number of ways to do something. So in chess, two queens are said to be attacking each other if they're positioned in the same row, column, or diagonal. How many ways are there to place two identical queens on the 4x4 chessboard so that they don't attack each other? So, oh yeah, by the way, so to do math, there are sometimes chessboard questions. So it's quite helpful if you play chess, or at least know the rules of chess. Right. I think in this case, you do get an advantage for knowing how to play chess. Okay, so if I draw the board for you, yeah, anyone has any thoughts? How do you get 44? You can, right. Is anyone else getting 44? Okay, I guess it's quite hard if you don't know how to approach this. So in general, the idea would be, let's say I put my queen here, then this will occupy this row, this column, this row, and this diagonal. So you can see I can put the other queen in 6 places. So that means that I'm now going to label this square with 6. So there are 6 configurations where the first queen is in that. By symmetry, of course, these are 6. Then let's say I put my queen here. This occupies this row, this column, this diagonal, and that diagonal. So I can put my other queen here. There are 4 places for me to put it. So 4. And obviously by symmetry, these are all going to be 4. If I put my queen here, this occupies this row, this column, this diagonal, and this diagonal. So I can put my thing here, 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 and here. So I also have 4 spots. Right? So now I just so now what happens if I add it up? If I add it up, I'm going to have how many is this? 64 plus 8, 72. Okay, I'm just gonna check if I counted correctly. My queen here. Oh, I didn't count correctly. Sorry, there's 2 points here. So it's 1, 2, 3, 4, 5. Oh, sorry. I need a different color. Yeah, okay. If I put my queen here, it's gonna occupy these diagonals. So I can still put another queen here. So there are a total of 6 spots here as well. Yeah. So all these will be 6. I think the middle one is still 4. So it's this. Yeah, okay. So middle one is still 4. So if I add all of this up, that's going to give me 12 6s and 4 4s, which is 72 plus 16, which is 88. So if you're getting 88, but the problem is they say you just put 2 queens, right? These are 2 of the same queens, which means you're going to double count if you put the first queen here and the second queen here and swapped, because in this case we are counting every unique configuration, but we're double counting every configuration because the 2 queens can swap. Sorry, so we divide by 2, and you're gonna get 44. Okay, so yeah. All right, and we have a geometry example. So in the following diagram, ABCD is a quadrilateral inscribed in the circle with center O. If AB is BC is 6 and AD is 14 and CD is the diameter, what's the length of CD? Okay. Can I have a think? Tell me what line you want to add. So in geometry, basically it's always about adding another line. So we'll go through, we'll go through intuition about what kind of lines you should be adding. Okay. Yeah. Because there are loads of possible lines that you can add. Okay, so in this case, this is not a very exciting question because you basically just drop a lot of heights and bash the problem. So you can just drop all the heights. So dropping all the heights is a very classic way of adding lines. So if you call these 7, and if you call the height y, and this will be 7, of course, because it's a rectangle. And in this case, because it's a circle, right, this will be a right angle. And if you call the radius r, this will be r. Okay, so that means that you now have some Pythagoras relationships, which is r squared is y squared plus 7 squared. And you also have, I mean, this is also r, so that thing is r minus 7. So r minus 7 squared plus y squared is 6 squared. So then simultaneous equations, calculate, do the algebra, and then you can get the answer. Right? Does anyone want to see the working? Or are you happy with this? Because this is it's just meant to be like an introduction session. So I'm gonna presume you can do the algebra and then you can solve for R. Okay, so lastly we have a number theory example. So if I write the numbers 1 to 2021 from left to right, and we read the result as an integer, what is the remainder when the number is divided by 6? So anyone knows any divisibility rule of 6? So anyone knows the divisibility rule for 6, or is then not really a divisibility rule? Right, exactly. So we should not be doing 6. We should be doing mod 2 and 3. And you can calculate mod 2. Clearly, the remainder is 1. And you can calculate mod 3 by adding up all the digits. Adding up all the digits is some tedious primary school thing that you can go and do. So you can get some remainder mod 3, and then you can combine it to be a remainder mod 6. Right? You just add up all the digits. And it's not particularly difficult because 1 to 9 is clearly divisible by 3. So every 1 to 9, you just throw away. And in particular, at some point after you're adding the digits, you realize you do not have to add all the digits. In fact, you do not have to add any of the digits. Right? So the divisibility rule for 3 asks you to add all the digits. But you don't really have to add all the digits or any of the digits, because the whole point of adding digits is to make life easier. But if adding digits does not make life easier, then you should just take the original number. So this is actually equivalent to just taking 1 plus 2 plus 3 plus 2, 10, 11, 12, and until 2021, right? Because the divisibility rule for 3 tells me it's the same thing for 2021 and 2 plus 0 plus 2 plus 1. Yeah, and this is just using the formula. Okay, and then you can take a remainder when divided by 3. The first number, then you do 2 plus 0 plus 2 plus 1. The remainder is 2. The second one is, okay, 1, 0, 1, 1 is clearly divisible by 3. So this is 0 mod 3. So now if you're looking for a number that's 0 mod 3 and 1 mod 2, well, what is that? That's 3. So yeah. So it's going to be 3, remainder 3 when divided by 6. Okay, amazing. So anyways, so here are some frequently asked questions. What's the difference between school and Olympiad math? So the thing about school math is they tell you the formula and tell you the method, ask you to do it. But the Olympiad needs you to think of the method. So they'll give you the question, but there are like so many methods, okay, about triangles, and so many ideas about mod or Fermat's theorem, or, you know, and eventually you're probably going to try something you've never done before. But with enough practice, the round 1 questions become basically routine work. This is not the case for most people because most people don't put in enough time. And you really need to, and honestly, I don't really advocate for putting in a lot of time to do round 1 questions. I recommend if you have lots of time, you should do round 2 questions. But obviously, nearer to the exam, you should do round 1 questions. So round questions are basically routine. It's just a whole bag of tricks that you have to learn. Round 2 is some original thinking. Now, Olympiad is extremely heavy on algebra, and essentially you never really get to plug in numbers. You get to play with numbers, but when you prove something or you write the working, it's all going to be algebra. So what do you need? You need a notebook because I'll ask you to copy down things. So I'll also send you notes. You can copy it on the notes if you want. But personally, I always keep a notebook, and you should probably file all your notes and not throw them away. Because I will often refer back to previous notes in the middle of the lesson. Okay, so yeah, and of course you need some time outside of class to do the homework and to do your own practice. Shouldn't be a problem if you're interested in math. Okay, so the time for this lesson will be Sunday, 7:30 to 9:30, and it will be basically every week except for major holidays, and the students and my exams, and occasionally some breaks. So on average, we plan to have about 40 to 44, maybe 48 lessons a year. Okay. Yeah. So if you join us a WhatsApp group for students, there's a WeChat group for parents, and there's a Google Classroom with AutoMark AMC 8 and 10 and 12 papers, and SMO Junior and all the SMO papers as well. Yeah. Okay. All right. So that's about it. Do you guys have any questions? Does anyone have any questions? I can answer questions in Chinese as well. Is MO results compulsory? Well, I would say as far as Cambridge goes, you are going to need some kind of edge. So the people who are here at Cambridge, they have IMO medals or IPHO medals or IOI, or research project medals, or some of them are, they have national, so like NOI medals, kind of thing. So I probably say yes, some kind of Olympiad result is needed. How is the difficulty of MC10 and how to prepare for it? So personally, I think MC10 is kind of like SMO Junior, except there are some questions in MC10 which is not in the Singapore syllabus. So there's a lot of quad geom and 3D geometry and so on that we don't really touch. So for those, it's quite, you need to spend some time to read for it. So in particular for MC10, there is this website, which is called Art of Problem Solving, where they have all the problems and also many, many solutions. So you can just do the paper and read the solutions and mark yourself. So the problems in MC10 are not extraordinarily difficult. But you do need to know basically all the knowledge that they require, right? So the starting bit is always going to be very trivial algebra, and then you need to know things like number theory, geometry, more algebra, more number theory, more geometry, combinatorics. So like it gets harder and harder. And the last few questions are basically a waste of time. So there are questions for people who are very, very smart and then they have nothing else to do. Okay, so how do you prepare for this? Well, you can just start by practicing a few papers and then see how well you do. And you can then collect like which topics, and you go and read the solution, right? So as far as my lessons go, if you have problems, you can just message me and then I can go through it in class. So the thing I always tell people is the more feedback you give me and the more you talk to me, the more personally tailored the lesson will be. Obviously to a limited extent because we still have notes to do. But yeah, I can answer questions about AMC during class time. So I think as far as Math Olympia students go, you should be comfortably able to qualify for AIME definitely by your 4th year, by Sec 4. Most people qualify for AIME in Sec 3. Sec 2 is pretty good. Yeah. So AMC 10 is not meant to be hard. It's just a lot of knowledge points that you need to know. Yeah. Okay, any other questions? Any other questions? Come on, there must be so many questions. Anyone has any questions? So the recording will be uploaded. So you can watch this again if you like. Yeah. Does anyone have any questions? You can type it or you can ask. Oh, somebody asked tuition fee. Yeah, so okay, so after today the schedule, like the time, the dates, and then the fees will be posted in the WeChat group. Is everyone in the WeChat group? Yeah, so the fees will be out shortly. The fees are collected every 2 months, and obviously if like your kid takes the lesson and then doesn't like it and then if you quit off, will refund you like the remaining lessons. But yeah, it's basically the fees are collected every 2 months. So usually for around 7 to 8 lessons. Okay. All right, so I guess there are no more questions. Oh, what will be covered in the number? You mean the Saturday class? Or the number theory part of this Sunday class? Okay, wait, I gave you an or and then you said yes. So which one? As in this, the class we're talking about now? Okay, so yeah, what will be covered is basically odd and even questions and also primes and composites. So it's just so let me share my screen. Yeah, so anyways, these are all my files. I've renamed the topic names a little bit since last time. So we have odd and even, which are just questions about odd and even. Not that it's very easy, okay? There are things that you need to think quite a bit about for odd and even questions. Anyways, so that's mod 2. And then for primes and composites, we have, you know, problems about finding primes, finding composite numbers, solving problems with primes in them. Yeah. And of course, we will cover things like generally how to take mod 3, mod 4, the remainders and so on. Okay, so number 3 is relatively light for SMO Junior because literally all you need to know is just the remainder rules and a couple of things about primes, couple of things about factorization, number of factors. Yeah. So as you get into so after this whole cycle finishes, in the next year, you'll be in the next level class, where there'll be more divisibility, perfect squares, stuff. So number 3 is pretty sort of, I personally think it's the easiest thing to pick up for SMO Junior. And then after that, there will be the advanced class where there is so much number theory because there are lots of theorems and stuff to talk about. And the SMO open class is also a lot of number theory. So number theory gets pretty hard as you go upwards. Yeah, but it's quite easy, I think, at the junior level. Okay, anything else? Did that answer your question? I'm assuming that you guys have done some primary school Olympiad, so you know things like divisible by 3 is the sum of the digits, divisible by 11 is the alternate digits. I mean, I'll recap it, of course. But I assume you've done enough of those that I don't really need to. We only really do them during the SMO round 1 practice papers. Okay, right, any other questions? If not, I look forward to seeing you in the class. As I said, all the details and the recording and stuff will be sent out shortly after this. Okay. All right. Thanks for coming. Bye.